Hi, I'm Catherine Laffey, and I did the Kern building for my project. Um, First, we started with the accessible approach and the entrance, and there's a route of travel, and the route of travel is not completely stable and actually needs to be paved. The route of travel needed to be at least 36 inches wide, and this route of travel was actually 76. There are no stairs at the main entrance, so there was no need for a ramp. There's no alternate entrance because the main entrance is accessible, and the entrance door needed to have at least 32 inches of clear opening, which it did, and it actually had 35. There's 30 inches of clear wall space on the pool side of the door, and it requires at least 18 inches. So they all worked. There is a wheelchair accessible button to open the door, and it takes 17 seconds to close, and it had to be longer than 3 seconds, so that was really good. The threshold edge was 1/4 inch high or less, and carpeting or mats were 1/4 inches high, and the maximum was going to be 1/2. So the door handle was 36 inches high, 48 inches high or less, and required quite a lot of force to get open with a closed fist. Possible solutions to the problems that I faced was to make both doors open instead of just one entrance when you enter. And also, I thought to make the non-slip mats built into the ground so that there's no possible way that someone using a wheelchair could slip or get caught onto the mats. The ramps were actually located when you first came in, and there was also one to get into the parking garage, and the slopes of ramps are at no greater than 1/12. All ramps longer than 6 feet do not have railings on both sides, and the railings were sturdy and are 34 inches high, and they had to have been between 34 and 38 inches high, so that met those requirements. The width between railings or curb are 43 inches high, and they must be at least 36 inches high. So those also met the requirements. The ramps are non-slip, and there's an 8-foot long level landing at every 30-foot horizontal length of ramp at the top and bottom of ramps and at switchbacks, and they must be 5-foot long level landings, so that also met the requirements. The possible solutions that I found for these ramps were to add non-slip surface material that would still be good for different outdoor weather conditions, such as if it were to snow and get slippery or there would be ice. Those ramps would not be good because there's no way for someone who was using a wheelchair or a cane to not slip. I also suggested to add railings to both sides of the ramps because there was only one side that had railings, and I also suggested create a better accessible ramp structure to make it easier for people to maneuver, because the way that the ramp was built was that it sharply curved at two different times, and I feel as though someone using a wheelchair, this would be very difficult for them to maneuver. The parking and drop-off areas. The parking garage meets requirements for having 5 parking spaces available for handicap. There are signs that mark handicap and van accessible spots that meet the requirements, and there are no accessible drop-off areas. Some accessible spaces are not close to the building, though, which would make it difficult for someone using a wheelchair or someone who is handicapped. The possible solutions I found for this is to put more handicap accessible parking spots in the parking garages and to make the handicap parking spaces closer to the elevators, because many of those spaces were actually quite far from the elevators, and I also feel as though if they can't do that, then add more elevators. The next section was access to goods and services. One part of this was the horizontal circulation, and the entrance provides direct access to the main floor lobby and elevator. There's a 5-foot circle and T-shaped space for a person using a wheelchair to reverse directions, and all public spaces are on an accessible route of travel at 38 inches wide, and the accessible route to all public spaces had to be at least 36 inches wide. So that also met the requirements. The possible solutions that I made for this was that some furniture could be moved around to make it more comfortable for people who are using a wheelchair or a person who uses a cane. The doors into public spaces have 35 inches of clear opening, and they needed 32 inches to meet requirements, so that was good. There's 18 inches of clear wall space, and it takes quite a lot of force to open doors all throughout the building. The door handles are all 36 to 45 inches high and are operable with a closed fist. The door handles had to be 48 inches or less, so this did meet the requirements, but it was not easy. Like, if someone had to do the closed fist test, it took quite a lot of force to push those doors open. All threshold edges are 1/4 high, and the possible solutions that I made for this was just to make the doors lighter in weight to make it easier. The rooms and spaces, all aisles and pathways are 36 inches wide. Not all spaces have a 5-foot circle or T-shaped space for turning a wheelchair around completely, especially in the sitting areas. There really wasn't much room at all for that. All obstacles are cane detectable though. Possible solutions that I found for this was rearranging furniture to make it more spacious, and also removing just some obstacles in the room and the space to make it easier for someone to maneuver in there. Emergency egress, there was emergency systems that provided both flashing lights and audible signals, and the signage for goods and services. Signs are mounted 60 inches from the floor, and they were mounted on walls that were adjacent to the latch side of the door. Raised characters were between 5/8 and 2 inches high with high contrast, and the signs did have Braille text of the same information, but not all of them had all of the information in Braille. For example, they would have the numbers, but what I used was, it said no food, drinks, chewing tobacco allowed in the room. A person who is blind would not be able to know that. So I suggest, for a possible solution, to put everything on the signs in Braille and not just the numbers. Directional and information signage. Directional and informational signs comply with legibility requirements. Signs are mounted above 80 inches with non-glare finishes, but they did not have letters at least 3 inches high. Controls that are available for use by the public was the water fountain, which was not at an accessible height, but it could be operated with a closed fist. My possible solutions for this was to move the water fountain down, and also to change the signs and just make them more with the requirements. The seats, tables, and counters. The aisles between fixed seating are 37 inches wide, and they had to have been at least 36 inches, so it just met the requirements. There is no wheelchair seating, but chairs can be moved inside to create room for a wheelchair. Outside seating, you can't do this at all, so the outside seating wasn't wheelchair accessible at all, because you can't move the chairs. Each cashier counter is no more than 36 inches high, except for the portion where the food is held over to the customers, which was quite high. Round tables are 28 inches high, 30 inches wide, and 14 inches deep, where the square tables were 29 inches tall, 36 inches wide, and 16 inches deep. Both of these met the requirements for the inches high and the inches wide, but neither of them met the requirements for the inches deep, which had to be 19 inches, and those both were, one was 14 and one was 16. So both tables were not deep enough. The possible solutions that I came up with were moving the seating around to make tables more accessible for people who use a wheelchair, and also creating a space for wheelchair seating so that they also have a place to sit. Vertical circulation. There are ramps, lifts, and elevators at all public levels. On each level, if there are stairs between the entrance and/or elevator and essential public areas, there is an accessible alternate route. For the stairs, they have a non-slip surface that's only at the edge of the steps, and they have continuous rails on both sides with extensions beyond the top and bottom stairs. So that also met requirements. But my possible solution for these was just to make the steps have a non-slip surface on the entire step and not just on the edge of the step. For the elevators, there's only visible door openings and closing and floor indicators, but no verbal or audio indicators other than a ding when you would reach a floor. The call buttons in the hallway reach up to 47 inches with only the first button being below 42 inches, but to meet the requirements, they must not be higher than 42 inches. So someone who would be using a wheelchair would not be able to reach the top buttons easily. The controls inside the cab have raised in Braille lettering. There are signs identifying the floor in raised in Braille lettering. So each floor that you went to, there would be the number of the floor you were on in raised letters, but not in Braille. The emergency intercom is not usable without voice communication, and the emergency intercom is identified by Braille and raised letters. The possible solutions that I did come up for these were to lower the call buttons or even just add something like a reach stick for those who cannot reach the top buttons. I also suggested to put more audible and verbal indicators for floors other than just a ding, so that if somebody who is using the elevator was a person who is deaf or a person who is blind, they would be able to know what level they are on without having to see or hear it. Put in a system that makes the emergency intercom usable without voice communication. I was suggesting using some type of video recording or iPad so that somebody would be able to communicate without using their voice. Usability of restrooms. So getting into the restrooms were available to the public, but they were not fully accessible for a person who uses a wheelchair. The doorways and passages, there are tactile signage identifying the restrooms. Pathways are only 32 inches and they must be 36 inches for a person who uses a wheelchair, so those were not met. Pictograms are used to identify restrooms, and raised lettering and Braille were also included below them. And no handles on outside of the door and inside. There was no handle on the outside of the door, and the inside of the door was accessible at 38 inches high and can be operable with a closed fist. Possible solutions were to make the passageways to the handicap accessible bathroom wider. The stall door is operable with a closed fist. There is a wheelchair accessible stall that has an area of at least 5 feet by 5 feet clear of the door swing. There are grab bars behind and on the side of the wall nearest to the toilet, and the toilet seat is 18 inches high, which it had to be between 17 and 19 inches high, so it made the requirements. The lavatories, handicap accessible stalls, has 30 inches by 48 inches of clear space in front. Lavatory rim is shorter than 34 inches, and it was only 18 inches high, so that worked perfect too. There's 29 inches from floor to bottom of lavatory. Apron, faucet is operable with one closed fist, and the soap and other dispensers and hand dryers are within reach range and usable with one closed fist. The mirror is above 40 inches high, and it slants down, so that makes it okay. Additional access I found were the drinking fountains. There is one fountain with clear floor space of at least 30 by 48 inches in front. The fountain spout is 42 inches from the ground and should be no higher than 36, so it was far too high. Controls are mounted on both the front and the side edges and are operable with one closed fist because all you have to do is press it. Water fountain is not cane detectable though. The possible solutions that I found for this was to lower the fountain or create a second fountain that is lower and handicap accessible. Provide cup dispensers for those who cannot reach the spout. And I also suggested to place a cane detectable barrier on each side on floor level so that people who use a cane would be able to detect it easily. The pros and cons of the current building that I found were the pros that current building meets almost all of the ADA requirements. The building is doing repairs to the bathroom to make them more accessible soon. I talked to a worker in the bathroom when I was doing my measurements, and she said that they were redoing the bathroom so that it would be easier for a person using a wheelchair to get to the bathroom and be able to use it comfortably. The signage meets ADA requirements and include Braille and raised letters on all of the signage, and the entrance is wide and accessible for a person who uses a wheelchair. Cons, the doors cannot be opened easily and need quite a lot of force to open. So even if they do pass the closed fist test, it required so much force that it would still be difficult. There's no wheelchair seating available, and the tables provided are not completely wheelchair accessible. The parking is not convenient for people with disabilities, and it is not easy for someone who uses a wheelchair to make their way around or reverse in the seating areas all throughout the building. The water fountains are too high and not cane detectable, and buttons for elevators are a bit too high and are not accessible for a person who is blind or deaf. The bathroom passageways also need to be widened, which I hope will be changed when they do the changes to the bathroom.